Alright, so we're going to practice solving a systems of equation using our Gauss-Jordan elimination method, and we're going to do it with this system right here. Now, I know I told you in the previous video that we typically use matrices to solve equations, to solve a system that has 3 or more equations in it, but because we're practicing this, we're kind of using baby steps to get into it. So the first thing I'm going to do in order to solve the system is rewrite this in its matrix form. So I know that it's going to have 2 rows because I have 2 equations here. Each row represents one of the equations from my system. So to write the augmented matrix, we're going to write a 3, -2, and a 14. That row represents the first equation. The second row looks like 1, 3, a 1. I'm going to put a vertical bar here to separate the left columns from this single right column, and that is now my augmented matrix. And that's what I'm going to start with. Now, the goal in solving this system is to get 1s all along the diagonal and 0s above and below. So if we have those 3 operations that we talked about before, looking at my equations that I have, or my rows that I have here, I want a 1. This is the first position that we're going to start with. We're always going to start trying to get a 1 in that first position up there. Well, if I simply swap these 2 rows, that's going to give me a 1 in the first position. So if I swap row 1 with row 2, it's going to give me a new matrix. So what will that look like? We're going to rewrite this over here. Row 1 is now, row 2 is now in the top. 1, 3, 1, and this top row is now in the bottom. 3, -2, 14. Now we're not going to use our calculator on this particular matrix because we can do most of this in our head, but we'll do it in the next one. So I have a 1 up here in this position. The next place that I want to go to is this right here. So after I get a 1 in this very first row 1, column 1 position, I want to go underneath it and I want to turn this into a 0. So 1's along the diagonal, 0's underneath. Now if I want this 3 to be a 0, and we can either swap rows, multiply rows, or multiply and add. This is the case when I want to multiply and add. So if I were to multiply row 1 by some number, add it to row 3, and I want the sum of those 2 numbers to be 0. This is kind of like our addition method, if you think about it, from when we solved systems algebraically, where I was trying to eliminate the x variables, let's say. So if I want this value to be a 3, I'm going to multiply -3 times row 1, -3 times row 1, add it to row 2, and that's going to give me a new row 2. So a -3 plus 3 gives me 0, and that's what I want right there. I want a 0 right there. And I put a little note up here that anytime I multiply and add to the row I want to change. So if this is the row I'm wanting to change, then I multiply and add to that row, creating a new row 2. So let's look at what that's going to give us now. The row 1 is going to stay exactly the same. So row 1 is going to stay 1, 3, 1. Row 2 is the one that we're going to change. So I'm going to multiply 1 times a -3, which is a -3, plus 3 is a 0. 3 times a -3 would be -9, and -9 plus a -2 would be a -11. -3 plus 14 would be +11. So that is my new second row, 0, -11, and 11. Once we have a 1 here and a 0 here, we're going to move to this diagonal position. This position is the one I want a 1 to be, right? So I want 1s along the diagonal. In order to make this a 1, we can multiply by its reciprocal, right? Or its conjugate, its reciprocal. So if I were to multiply row number 2 by a negative 1 over 11, that's going to give me a new row 2, because negative 11 times 1 over 11 is simply 1. And that's when we do the multiplying a single row. So we can just keep on going this direction. If I do that, again, I haven't done, notice that I'm only doing an operation on row number 2. So row number 1 is going to stay 1, 3, 1. 1, 3, 1. Row number 2 is the one I'm multiplying by negative 1 over 11. We did that because 0 times anything is still 0, and I worked really hard to get a 0 here, so I want that to stay a 0. Negative 11 times negative 1 over 11 is a positive 1, and 11 times negative 1 over 11 would be negative 1. So there's my new row 2. I have 1s along the diagonal, I have a 0 below, and so now I want to move to this position. This is the guy that I now need to get a 0. Anytime I'm trying to get a 0, I typically do the multiply, add to get a new row. Okay? So since I want a 0 here, I'm going to multiply, and this is the row that I'm wanting to change. So I need to multiply and add to row number 1. So I'm going to multiply row number 2 by 3, negative 3. So negative 3 times row number 2, because a negative 3 plus 3 is 0. And I'm going to add it to the row number 1, because row number 1 is the row I'm trying to change. And that gives me a brand new row number 1. So just because I want to be able to see all this, I'm going to go down below. So let's go down this way. So if I were to multiply 0 times negative 3, that's 0, plus 1 is still 1. Okay, that's why this is going to work this way, because by multiplying row number 2 by something, adding it to row number 1, it's row number 1 I'm ending up changing. So 0 plus 1 is still 1. Now, negative 3 times a 1 is a negative 3, plus 3 would be 0, and negative 3 times a negative 1 would be positive 3. 3 plus 1 would be 4. And the second row did not change. This stayed as 0, 1, negative 1. Okay, so what have we found? We have 1s along the diagonal, 0s above and below. This is my solution matrix, giving me the answers to my system here in the rightmost column. So again, this is the answer column. This says that my x variable is equal to 4 and my y variable is equal to negative 1. And that is the solution to this systems of equations using the Gauss-Jordan elimination method.